So when I say the word computer, what pops into your head? Probably a laptop, right? Or maybe a desktop tower. But what if I told you that you probably use dozens of computers before you even finish your morning coffee? Today, we're going to pull back the curtain on the vast and often hidden world of computers. First, we're going to uncover all the secret computers hiding in plain sight all around you. Then, we'll figure out how to classify them by their massive range in size, by their specific purpose, and even by the fundamental language they speak. And finally, we'll reveal the invisible network of computers that truly runs our world. So, let's kick things off with a simple question that has a surprisingly complicated answer. No, really, take a second and actually count them. 1, 2, maybe 3 if you have a phone and a tablet. Well, I'm willing to bet the real number is way, way higher than you think. Your smartphone is obviously a powerful computer. We all know that. But so is your smart TV. The system running your car, that's actually a whole network of them. Even your washing machine, your digital watch, and your microwave oven have small, dedicated computers inside just to do their jobs. To make sense of this huge variety, we can kind of sort computers into a few key buckets. We'll look at them based on their size and power, their specific purpose, and finally, the very type of data they process. Okay, let's start with our first classification, size. And we'll begin with the computer in your hand and scale all the way up to machines that can simulate entire galaxies. Seriously. So at the base of the pyramid, we have the microcomputer. This is probably what you thought of earlier. It's any small, relatively inexpensive computer designed for an individual user. This category includes everything from desktops and laptops to your tablet and your smartphone. Now, let's scale things up. A lot. A mainframe computer is an absolute beast. These aren't for individuals. They are massive machines used by large organizations like banks, railway networks, and government departments to process huge amounts of data from thousands of users all at the same time. And at the very top of the pyramid, we have the supercomputer. These are the absolute pinnacle of computing power. They are the fastest, most powerful machines on the planet, built to tackle enormous problems like complex weather forecasting, nuclear simulations, and deep space research. To put their power into perspective, we're not talking millions or billions of calculations per second. A supercomputer performs trillions of calculations every single second. For you to do what one of these machines does in 1 second, you'd have to perform one calculation every second for over 31,000 years. It's a level of speed that is it's truly hard to wrap your head around. Okay, let's switch gears to our second classification, purpose. Here, the question isn't how big is it, but what is it designed to do? You can think of it as the difference between a versatile multi-tool and a highly specialized wrench. First, you have the general-purpose computer. As the name suggests, it's designed to be a jack of all trades. Your laptop is the perfect example. You can use it to write an email, edit a video, browse the internet, play a game. It's built for versatility. On the other hand, we have the special-purpose computer. This machine is a specialist. It's designed from the ground up to do one thing and do it perfectly. An ATM is a great example. Its only job is to handle your banking transactions securely and efficiently. That's it. And this comparison really highlights the core trade-off. A general-purpose machine like a PC offers incredible versatility, but a special-purpose machine, like the one running a traffic light system, sacrifices that flexibility for extreme efficiency and reliability in its single crucial task. All right, our final classification is all about the fundamental way a computer processes information. You could almost call it the language it uses to interpret reality itself. First up are analog computers. These machines don't count, they measure. They work with data that is continuous and flows smoothly, like the rising temperature on a thermometer, the changing air pressure, or the increasing speed of a car. In contrast, a digital computer works with discrete data. It breaks everything down into separate, countable units, specifically numbers represented by zeros and ones. So the crucial point is that it counts instead of measuring. Almost every computer you use today is digital. This slide really clarifies the distinction. Think of an old car speedometer. The needle moves in a smooth, continuous arc. That's analog. Now think of a modern digital watch. The numbers don't flow. They jump from one distinct value to the next. 501, then 502. That's digital. And there are also hybrid computers, which combine the best of both worlds.
They take in continuous analog data, like a patient's heartbeat, and use powerful digital processors to analyze it. You'll find them in really specialized fields like medicine and scientific research.
So let's bring all of this together. We've seen computers classified by size, purpose, and data type. But the biggest takeaway is realizing that we live inside a vast, interconnected network of these machines, most of which we never even see. And this brings us to a crucial term, the embedded computer. This is a special-purpose computer that's built directly into another device. It's the hidden brain that gives an object its smart functionality. This connects right back to the secret computers we talked about at the very beginning. I mean, think about your day. When you visit a website, you're talking to a server, a powerful computer that stores and sends data. When you drive, dozens of embedded computers manage your car's engine and brakes. The controller in your smart TV, the system running the traffic lights, the chip in your microwave, it's all part of this hidden network.
So this is the ultimate takeaway. The term computer isn't just a box on your desk anymore. It's an entire ecosystem of machines, big and small, seen and unseen, all working together to make our modern world possible. So I'll leave you with this thought. As this trend continues and virtually every object from your shoes to your coffee mug gets its own tiny embedded brain, what does the word computer even mean anymore? What do you think the future holds? Something to think about. Thanks for watching.